So in today's video, we are going to see threaded binary tree. Okay, threaded binary tree which makes use of null pointers to improve its traversal process. How the threaded binary tree it improves the traversal process mean when we are finding the traversing the tree. What we have to do means just we are starting from root. We go to the left node up to deepest node. Then after reaching H, we have to examine the left node again, because we don't know that whether H is having left child or not. After examining that, if it is null, we return back again. Then we have to come check the right child also. So when we are examining the left child and right child of H, it is waste of time. Okay, so how many times we are doing this means it is the nature of the binary tree. For example, suppose what is the root node level? Root node level, it is 2 power 0. What is that? 2 power 0. 2 power 0, it means that it is one single node. What is the second level? Second level, it is 2 power 1. It is 2. 2 nodes are there. What is the third level? Third level is 2 power 2. Okay, so 2 power 2, it is 4. So like way, whenever we are going each and every next level, it is 2 power next number. Okay, so you imagine that suppose it is the 15th level. So we examine the 16th level means 2 power 16. So 2 into 2 into 16 times we have to multiply. That much of node we have to examine in the deepmost level. Okay, so this is totally waste of time. The time it takes more. So that's why two members, that is two authors, A.J. Perlis and C. Thornton, they are making one new tree. It is called threaded binary tree. Okay, so in that threaded binary tree, it is also a binary tree in which all left child pointers that are null. What are all the left child pointers that are null? So whatever the tree I am giving here, I am giving the linked list representation of the same tree I am representing here, I am giving here. Okay, the left child pointers that are null in a linked list representation. Why it is mentioning it as linked list representation means in linked list representation only we come to know that whether the left child and right child is there or not. Okay, so that's why we are representing the linked list representation. Left child pointers that are null in the linked list representation points to its in order predecessor. What is it? It is in order predecessor. Then and all right child pointers, left child pointers means whatever the left child pointers are there. Okay, left child pointers, and right child pointers means right side child. So all the right child pointers that are null in a linked list representation points to its in order successor. Okay, so now I want to clarify what is in order predecessor and what is in order successor. What do you mean by in order predecessor? Before we are we are going for an in order predecessor. What is in order? Okay, so we already have an idea that there are three terms are there as far as the binary tree is concerned. What is it? In order, pre-order and post-order. Okay, if you have any doubt, I already post the video. Just go to that video. I'll give a link. Go to that video, get some information from that video, and then you come here. Okay, so what is in order? In order, it is nothing but left top right, left root right, or left top right. So in order traversal, suppose I am taking this tree. What is the in order traversal of this tree? This tree, it is first we come to leftmost child, then we are considering the root node, then we are coming for right child. So left top right. So in order, it is nothing but what is it? Left top right. Okay, so as per left top right, we come to the leftmost child, then we start from here. H is the first node. Okay, H is the first node. Second node is, this is the subtree of that particular B. So in that subtree, we have to follow the left top right. H, D, D, then I. Okay, I. Then we come here, B is next because left is over for B in the subtree. Then left is over top, then right. Right is E. And for this whole tree, this is left subtree. This left subtree is over. Next one is top. Top is A. Then we come to right. Even though we come to right, we go to again left because order is left, top, right. So that's why we go to left. So there is no left for F. So that's why it is F. Then right. Then top. Top is C. Then G. So this is we call it as in order traversal. This is we call it as in order traversal. What do you mean by traversal? Traversal, it is nothing but traversing a tree, traversing all the nodes in a tree. The fashion of traversal, it is in order traversal. Okay. So this is what the in order traversal. Now I come to the point. What is the point? Left, what is it? Which all left child pointers that are null. What are all the left child? Left child is this one is left child. And what about this? This one is left child of C. And there is no other left child. So in order predecessor. What do you mean by in order predecessor? Suppose I am taking, what is it? I am taking H. I am taking, for example, I am taking H. In H, in order predecessor, what are all the terminal nodes for H? And this side it is, what is it? This is H and this is G. I made a mistake. This is G. Okay. So G is given here, H is there. So in H and G, the leftmost part, what is it? For H and G, this is the terminal nodes. The terminal nodes are don't have any in order predecessor. H's don't have any in order predecessor. What does in order predecessor mean? Suppose I am taking D, in order predecessor is H, in order successor is I. When we are constructing the in order traversal, whatever the, suppose I am taking B, in order predecessor of B is I, in order successor of B is E. Okay. So like a way, we are taking the in order predecessor for all left child. So what is it? In order predecessor. If it is a terminal node, that terminal node which is connected to root. Okay. So this is what the idea. So the terminal node, this one which is connected to root, because this is the special case. Like a way, in the last this terminal node, what is it? When we are considering the in order successor, G, it don't have any in order successor. So that's why G, this node which is connected to, this is also connected to root. Is the point clear? Or the terminal nodes in the both side, H is not having any in order predecessor, G is not having any in order successor. In those special cases, we are connecting those links to the root. All others, suppose what is it? H, this is the right child. So which is connected to, what is it? Right. It means that in order successor. What is in order successor of H? H in order successor is D. So that's why this is connected to D. What is I in order predecessor? What is I in order predecessor? In order predecessor is D. So that's why D it is connected to here. What is in order successor of I? In order successor of I is B. So that's why this is connected to B. Is the point clear? What about the in order predecessor of E? In order predecessor of E is B. So that's why this is connected to B. Okay. And in order successor of E is A. So in order successor which is connected to A. And what about the in order predecessor of F? F predecessor is A. So that's why this is connected to A. And already it is there. What is the in order predecessor of J? J predecessor is F. So that's why predecessor which is connected to F. Then what is the in order successor of J? It is C. So which is connected to C. Okay. Then what is G? G in order predecessor is C. There is no in order successor. Predecessor is available. In order predecessor of G is C. So this one is connected to C. What is it? This is what we are doing to avoid the, what is it, unnecessary examining of the terminal node after the terminal node. So this links we call it as threads. So through this threads only we come to understand that there is no further nodes in the binary threaded binary tree. Okay, so this is what the idea. I hope you understand this.